Hello car, this is my ASMR channel.
Ready?
Yeah, go.
Katie is behind the camera today, and we decided that trying to understand the actual engineering behind human-machine interfaces is best done over a glass of wine.
No.
We don't.
No, let's restart. Let's restart.
Alright, so
No, what are you going to say instead of that? Because if you don't have wine, it's just...
don't worry about this sweet stuff. Katie is behind the camera today, and we decided that trying to understand the actual engineering behind human-machine interfaces is best done in a Q&A fashion. So let's get going. What questions do you have?
Every time you talk about brainwaves and muscle hacking, my brain... No, I need to read it out.
Katie is behind the camera today, and we decided that trying to understand BCIs and...
Look at the camera! Stop!
Don't worry about the camera.
No, I think you need to talk to the camera.
No, just relax.
Okay, move your phone though. I don't like your phone though.
It's not in the shot. Don't worry about it.
I think you should look at the camera.
I can edit it.
No, you can't.
Yes, I can.
You can't edit your eye.
I literally do. Okay, Katie.
It's behind.
Katie is behind the camera.
No, you're laughing now. BCI, what does that actually stand for?
BCI stands for brain-computer interface.
Okay, so how does that work?
Okay, so BCI is costly, complex, but fundamentally it's just a language translator. Your brain communicates internally using tiny electrical signals firing across billions of neurons. A digital computer communicates using binary code, so that's ones and zeros. Obviously, biological tissue and silicon chips can't talk directly, so a BCI is basically the hardware and software that sits right in the middle of that gap. It uses specialized sensors to listen to those electrical signals, and it filters out the massive amount of background noise and translates them into digital commands a computer can actually understand.
Okay, so it's basically turning a thought into a digital action.
Yeah, basically. You think about moving a cursor to the left, right? Your motor cortex fires a specific pattern. The sensors catch it, and the cursor moves without you lifting a finger. Kind of like magic. Whether it's a high-tech chip implanted directly into your skull, like what Neuralink is doing, or a completely non-invasive stylish headband tracking your alpha waves and beta waves from the outside. If a thought moves through a digital asset, it's a BCI, or brain-computer interface.
Okay, I can see that. It's a translator for the brain.
Yeah.
So what about EMG? What's the difference between reading the brain and doing whatever EMG is?
So an EMG stands for electromyography. It shifts the focus from your brain to your peripheral nervous system and your muscles. Think about the physics of how your body actually moves. When your brain decides to move your arm, it sends an electrical action potential down your spine and out through your limbs. The exact millisecond before your muscle physically flexes or moves, it emits a tiny measurable burst of electricity. So EMG is the technology that uses highly sensitive electrodes placed on the skin to intercept that muscle electricity before a full physical movement even happens.
Wait, so you don't even have to fully move your arm for the computer to register it? That's
Yes.
so cool.
It's like it knows what you're doing before you even do it. A tiny twitch of your wrist or a micro contraction of your forearm that's completely invisible to anyone else in the room still emits enough microvolts of electricity for an EMG sensor to capture it. Instead of typing on a physical keyboard, pressing buttons, or moving a mouse, your entire skeletal system becomes the input device. You can control an entire digital dashboard just by subtly tensing different parts of your arm while sitting completely still.
So bio-integrated interfaces, it sounds very futuristic. What does it actually look like in the real world?
Bio-integrated interfaces is a really interesting term because consumer technology is completely external. Think about your iPhone. It's a flat glass smartphone on your hand that you have to stare at. Or think about VR headsets. It's bulky, it's strapped to your head, and it cuts you off from reality. It forces you as a human to adapt your posture, your eyes, and your movement to that. A bio-integrated interface flips that entire philosophy upside down. It means designing technology that treats your biological inputs like your heartbeat, your skin, your muscle twitches, and your brain waves, not as passive medical data, but as raw interaction interactive inputs for actually creating interaction between yourself and technology.
So the technology is adjusting to our bodies instead?
Yes. Instead of a device that you're holding and interacting with through a screen, the technology is woven seamlessly into the fabrics that you wear, the jewelry that you put on, or the smart materials interacting directly with your skin. It blends structural utility with human form, so the technology completely adapts to your natural biology and your cultural expression rather than forcing you to act like a robot just to send a text message or control your environment.
Oh, okay. I actually get it now. Brainwaves for BCI, muscle signals for EMG, and bio-integrated interfaces to make it wearable and human.
Yes, that's basically it. We're going to be putting these exact concepts to the test and prototyping real physical hardware right here in the studio over the coming weeks. And if you want to see how we actually turn these biological signals into working technology, drop a comment with what tech you'd want to control your mind with, and we'll see you in the next one.